Question number 35. A binary liquid mixture prepared by mixing two liquids in a closed evacuated container at a given temperature shows a negative deviation from Raoult's law. Which of the following statements is correct for the system? Let's say two pure liquids called A and B, say A here, P naught A here, is mixed with a pure liquid B, saturated vapor pressure of B here, and we get a negatively deviated solution. So it's a totally miscible mixture. What is the meaning of totally miscible? Negative deviation. Now here the total pressure will be PA plus PB. When we consider the intermolecular interactions of the pure liquids, let's say in the liquid phase, the intermolecular interactions are F, A and A. In the liquid phase of B, F, B and B. So these are the intermolecular forces of the liquids, of the pure liquids. And the newly formed interaction is FAB. When they are mixed completely, they form interactions with each other. So that is why their vapor pressures are decreased. Now, if FAA is equal to FBB and equals to FAB, the newly formed interaction is equal to the intermolecular interactions of the pure liquids, then it is called an ideal solution. Ideal solution. Now a negative deviation is formed when the newly formed interaction is stronger than pure liquids. So AB intermolecular force is greater than both A and BB. I hope you can understand this. The newly formed interaction is greater. For example, let's say this is a dipole-dipole interaction. This is a dipole-dipole interaction. But when they are mixed, it forms a hydrogen bond. Let's say, for example, now a well-known example for that kind of situation is chloroform and acetone. When chloroform and acetone are mixed, they form hydrogen bonds with this hydrogen and this oxygen. A hydrogen bond is formed. But when the pure liquids are considered, CHCl3 or the chloroform doesn't form hydrogen bonds itself. Acetone doesn't form hydrogen bonds. They are just forming dipole-dipole interactions separately, but when they are mixed, the hydrogen from the chloroform has a high polarity and the oxygen has a high polarity with lone pairs. The newly formed interaction between these two molecules will be hydrogen bond. So hydrogen bond is a stronger bond. When the newly formed interaction is stronger than the initial situations or the initial pure liquids, it is called a negatively deviated solution. Negatively deviated solution. It is called negative deviation because the vapor pressure here, the total vapor pressure is lesser than the total vapor pressure of an ideal situation. Sorry about that. Lesser than the ideal situation. Right. So the evaporation is limited now. It's decreased. Let's go to the statements. First statement A. Total vapor pressure of the mixture is less than the expected total vapor pressure should it behave as an ideal mixture. That is true. That is why it is a negative deviation. Statement B. Heat is released when the mixture is formed. Right. Now the weak interactions are dissociated and strong interactions are formed. So when the weak interactions are dissociated, a smaller heat is absorbed strong interactions are formed, so a large amount of heat is released. Now please remember, when bonds are being broken, heat energy is absorbed. The opposite is also true. That means when a bond is formed, heat energy is released. Let's write that down. Bond dissociations are endothermic. Bond dissociations are endothermic. Bond formations are exothermic. So which means thermal energy is released here. Alright, since weaker bonds are broken, stronger bonds are formed, the net result will be the heat energy will be released because the formed interactions are stronger. Therefore, this statement is also correct. Heat energy will be released. And that's the reason when we mix sulfuric and water, the heat energy is released, because sulfuric forms hydrogen bonds, water forms hydrogen bonds, but when they are mixed with each other, they form ion dipole interaction. Therefore, the newly formed interaction is very strong, so net heat energy release is there. Alright. Statement C, number of molecules in the vapor phase of the mixture is greater than the expected number of molecules should it behave as an ideal mixture. This is wrong, since the liquid phase, now these interactions are defined for the liquid phase. It determines the volatility. If the newly formed interaction is a strong one, the volatility is decreased. Therefore, if it was ideal, then a weak interaction is formed here, so it will be more volatile. But the newly formed interaction is very stronger than the ideal situation, therefore the volatility will be decreased. Therefore, we cannot expect more gas molecules just as in an ideal situation. Statement D, heat is absorbed when the mixture is formed. No, it's wrong. We saw that the B statement is correct, so if the B is correct, D is incorrect. So the answer will be A and B, therefore the answer will be first one. Okay, let's move on to the next question.